Hey, Vlad here, devinsideu.com. Welcome to another video. By now we're more than 30 videos deep into the Homegrown collection series, but if we look at our results and be honest with ourselves, we only implemented sets and maps, and both of them are unordered collections. Not too long ago I made a few videos about the ordering type class, and my initial plan was to start making videos about ordered collections right after that. But then a few other things interrupted that flow, and I made, for example, the recent Monad series. Well, now the time has come to finally start talking about ordered collections and also find out why to this day juniors are still asked to reverse string in job interviews. Let's get right to it. As always, we're in the Ubuntu virtual machine and we're running Sublime Text, which is the editor of my choosing, which is fully maximized. And we're also using a plugin called Terminus, which emulates the entire terminal for us, which we use to run SPT, which we use to rerun the tests every time we save the file. Alright, so today we're going to talk about lists, arrays, vectors, and strings, which are all ordered collections, but they have very fundamental differences. And by the way, guys, today we're not going to commit anything to the Homegrown collection series. We're just going to play around with a few ordered collections. Vectors are slightly less known, but lists and arrays are usually the very first collections that are introduced to young developers. And I guess everyone knows what strings are, right? Right? Imperative programmers are introduced to arrays and functional programmers are introduced to lists. But why haven't I introduced you to these two and went through 30 videos of sets and maps instead? Well, one of the reasons is that sets are the fundamental building blocks for a lot of things in mathematics. And another reason is that ordered collections are highly misunderstood creatures. They seem very simple at the first glance, but have a lot of hidden complexities, maybe even more than sets. Let me show you an example. It is common to ask junior developers to reverse a string during a job interview, and you will be shocked to find out how many find it challenging, to say the least. Let's implement it real quick, shall we? So what we're going to do is we're going to go over here. We're going to open our source, main Scala, homegrown collections, and just throw in a file over there, and we're going to call it reverse.scala. All right. So let's also put it in the package homegrown dot collections. Okay, so we're just going to create an object reverse. It extends app, and we're going to print out my favorite hyphens, which I have from here, times 50, like that. Print out hello world, and now let's switch to actually running that main. So we can do run main homegrown collections reverse like this, and we should see hello world, and we don't need that much space, so I'm just gonna do that. Let's see. All right, yeah, that should be enough. In modern programming languages, reversing a string is trivial because methods for reversing a string are built into the standard library, right? So ta-da, we're done. Or as Anthony Mackie would say, cut the check. Now, this is not what is usually expected during interviews, so let me type out a slightly longer solution real quick. Also, I'm going to copy my hyphens and put them in there like this. Okay, so let us be very explicit about what we do. So let's say that we have an input, which is a string, which is hello world, like this. And then we're going to convert it into array. So we're going to have input as array. And today we're going to talk about arrays a lot, actually. So we're going to have input to char array. So the method to char array is already built into strings. Okay, then we're going to get the length from this array, input as array dot length, which should be 11, right? Don't forget the space. So now we're going to have buffer as array. This is going to be an output buffer, right? So this is going to be an array of characters, array, and you can create an array by giving it a length, right? So you can say array of a dimension, and you can give it the length, right? Which is 11, right? So this is now an array of 11 elements, and it's an empty array. Okay, so now we're going to have min index, which is an integer 0. So arrays go from 0 to max index, which is length minus 1. Okay, right. So now we're going to have a loop, which if you have seen my videos about for comprehensions in Scala, a for comprehension is actually not a loop. It is actually a bit more powerful. So we're just going to go from min index to max index, and we're going to go over here, and we're going to say that buffer as array at the place of max index minus index, and that it now should be whatever was in the input as array at the index position. So now after the for comprehension, or after the loop, we're going to have an output, which is a string, and we can create a string by just passing it as an argument, an array, right? So this is a uncommon thing to know, actually. Okay, and then in the end, we're going to print out the output, and we're also going to print out print out the output dot size like this. Let's see if I made any typos. It looks like I didn't. Cool. Let me say a few more things about this. So strings, usually in most programming languages actually, they're backed by arrays. So behind the strings are arrays. So strings are just wrappers around arrays. The implementation details, they vary on your JDK version though. Okay, so because strings are just wrappers around the arrays, and in modern programming languages like Scala, you can also retrieve each character by its index straight from the string. So we didn't have to create this input as array thing. I'm pretty sure that we can just go to input and do it directly. We're not going to do it though, but you know, you just can. Now, this is arguably one of the simplest programs out there, but in the traditional imperative style, it already requires quite a bit of code, which I emulated here in Scala, right? The imperative style, which is uncommon for Scala. Also, let me scroll down a little bit so that you see the entire thing. Okay, maybe more like this. Kind of prefer that you see the entire scope, like from this brace to this brace. Let me save again. Yeah, the entire output still now almost fits in like that. All right, there we go. Maybe not like that, like that. Oh, come on, give me all the space like this. There we go. Okay. Notice also that it is a common misconception to think that imperative programs are full of vars. Look, we don't have any vars, but our program is still full of mutation and this step-based thinking. And not only are there many solutions to this problem, even this solution that we have right here, it also has many variations, because in imperative style, we say explicitly how we want to compute things. So for instance, we can go over here, and instead of going from left to right, we can also go from right to left, right? So we can go from max index to min index by -1 like this, and it should behave exactly the same. Also, we could, for example, swap these, right? So we can say that there will be an index over here and the max index -1 over here, right? It should behave exactly the same way. And by the way, if you're wondering how this is implemented in Scala, Scala has this wonderful method called update, where you can pass the first parameter would be the index, and the second parameter would be this, right? So this code is exactly the same as this code over here, right? Okay, cool. Let me revert that. Let's have I don't know, let's have this one, for example, and let's have the initial one. I think it's prettier like this. Now, why am I showing you all this? I'm showing you all this because this very simple code requires quite a bit of knowledge and a lot of assumptions to be made. And I'm not talking about some syntactical juggling and some intrinsic Scala skills. I'm talking about very fundamental things. For instance, the problem assumes that order is involved. Well, duh. What else is new? Secondly, it assumes that strings are collections of fixed length. This particular solution also assumes that arrays are also collections of fixed lengths, and also that you can create them without specifying the elements, but instead just specifying the size. So an array can be sort of empty, so it is assumed that arrays are also mutable. And because they're mutable, we can also interpret that the solution requires some extra memory to be available for the final result to be computed, right? So this is what arrays are for. You create them, they're empty, and then you fill them. This particular solution also assumes that the elements of the array, they don't need to be accessed one by one. They can be accessed at a random position by an index, like over here. What happens if the element at the requested position is not there is not clear, at least from the types is not clear, right? So the return type of this function is integer, but what if it's not there? Also, what if you pass in a negative integer as an index? You don't know. What if you pass in an index that is greater than the length of the array? You don't know. And when I say you don't know, I mean you don't know from the type. And if you don't know it from the type, then this is some intrinsic knowledge that you, as a junior developer who's being interviewed, is supposed to know. And this is, these are all the reasons why such a simple program is requested from junior developers, because you can ask them so many questions about this. For instance, is it possible to replace an element that has already been inserted? Probably. Can you insert elements at any order? I guess so. Also, because the problem statement doesn't specify any lengths of the input, which could be potentially millions of characters, the current solution, which uses arrays, assumes that retrieving an element at this index and also writing, right? So the read access and the write access should be reasonably fast. And as I already mentioned, all of these are perfectly valid reasons to use this example in a job interview. Allow me to explain how arrays work, and for this we need to understand how memory works. Obviously, we're not going to go into details, so my explanation might be a little bit hand-wavy, but we just need to conceptually understand how memory works, okay? So let's get right to it. Think of memory, specifically RAM, as an ordered list of slots, and for simplicity's sake, let's say that every slot can accommodate only 1 byte of memory, and the slots are enumerated. Usually in math, you would start enumerating things from 0, but for simplicity's sake, let's say they start from 1. So they go 1, 2, 3, 4 until your memory runs out. When an application is started, the operating system assigns a range of memory to your application. Let's say from 123 to 456. And then in any modern programming language, as soon as you create something inside of your language, like an object or a number or anything like that, the memory is dynamically allocated somewhere within this range, so somewhere between 123 and 456. For instance, an integer on the JVM requires 32 bits of space. 32 bits of space are 4 bytes, and therefore you need 4 slots. So let's say that your integer is going to lay on the slots 201, 202, 203, and 204. And if you create another random integer, then it's going to be positioned somewhere else. For example, 341, 342, 343, and 344. Sometimes you might want to store several integers that are related to each other, or in our case, we have different characters that are related to each other, so they're stored in one string. This fits into the definition of the English word array, and I'm just using the English word array and not the computer science concept of arrays, right? So just the English word array means that it's just a sequence of something, okay? And the operating system will ensure that all of these, like in this case, all of these characters, or in case of the integers, all of the integers, that they will be stored right next to each other in memory. So when you create an array, you specify in your programming language which elements are going to be inside of an array. For instance, over here we say characters, but in my example we have integers, and also how many of them you want to be able to place in there so that the operating system can allocate enough memory for it. As we already know, an integer needs 4 bytes, and so if you create an array, we should be able to hold 10 integers inside of it. Well, 10 times 4 is 40, so the operating system will give you 40 slots in this already given range for the entire application. So for example, from 301 to 340. Now in a lower language like C, you have access to the actual memory, and you can do some memory arithmetic, which is usually called pointer arithmetic, to arrive at your elements by just calculating the address. So it's not like in a list where you have to go through all of the elements to arrive at your element. No, you can just calculate the address, point the array to this address, and it will retrieve it from memory. Now we're using Scala here, so we're sitting somewhere on the top of the JVM, and we don't have access to memory, but we don't need to, because the JVM guarantees that the arrays are implemented with the lower level arrays of memory. And so even though we don't know exactly where our data lies, we know that it lies right next to each other. And so the access time, both read and write, to arrays is constant time. By the way, the memory itself is effectively an array, which also justifies the actual name for this kind of memory, which is RAM, which stands for random access memory, as opposed to direct access memory, which unfortunately nobody calls DAM. So arrays are the canonical representatives of imperative programming, in which you mutate things in place. And the key word is in place, because we're literally talking about locations in memory. A rather functional way to look at arrays would be to look at them as mutable maps which are ordered by its keys, and the type of the keys is fixed to be integers, right? It's just a position. Also remember that maps are essentially functions from key to value or key to option of value, depending on what's more important to you. Since maps are usually backed by some sort of tree or a hash table, the algorithmic complexity of most operations is logarithmic, and so arrays outperform maps because the algorithmic complexity there is constant. All you need to do is to calculate the address of the element that you need and just go straight for it. Let's try to simplify the solution a little bit. Now, these days, even Java has better access to the elements of the array instead of going through the index, but it's not going to be enough, as you will see in just a few seconds, because we're still doing imperative programming, and therefore we're more concerned about where things are instead of what things are. So, for instance, instead of going through the indexes, we could do something like this. So instead of, I'm going to comment this out. And we can try something like this. We can say for the character in the input as array, and as we have already seen, we can just go to input as well, but let's just do that. So if you wanted to do this, right, then we still would need to know in the output array output array, how did I call it? I call it buffer as array. Buffer as array, if we still need to know where to put it, right? Because we're still doing imperative programming. I'm sorry, like this, right? We're still doing imperative programming, so we still need to know where things are instead of what things are. Well, how about if we don't use arrays as our output? What if we use strings directly? So if we go over here and we say output string, which is just a string, okay, and it starts empty, right? Then over here we can do, instead of working with indexes, we can just go to the output string, and we can say that its new value is going to be output string plus this character. Then in this case, we're not going to need the index, and we're not going to need this because it's just going to be output string like this. And I wish I could type, Jesus, output string. There we go. It's kind of cold in here. Okay, so now I can remove these. We don't need them. I'm going to leave this comment over there for a bit. Okay. Okay, so now this compiles, but as you can see, it actually doesn't reverse anything. Why doesn't it reverse anything? Well, because we're going in the string from left to right, and we're also appending from left to right. By the way, we're not actually appending anything to the string because strings are immutable. We're actually creating 12 different strings over here, right? And this is also why we were forced to use a var for the first time. So even though, as you have seen in the beginning of the video, the strings themselves, they're backed by arrays. Arrays are mutable, but strings are immutable. So if we wanted to use this kind of solution, we would actually need to use indexes again. So we can go index, we can say max index, which I just removed, max index to min index by -1. This is what we had in the beginning. So let me put it again. So we're going to have min index, which is 0, and max index, which is going to be length -1. Oh, come on, 1. There we go, like this. And also now we need to access it by the index, so we can have a char over here. We can say input as array, and we can pass it the index, and now we should be good. One thing to notice here is that because we're using more and more immutable constructs, we're closer and closer to the functional programming. And just as a coincidence, I guess, the solution space kind of shrunk. Before, we could decide in which direction we're going, but over here, we're sort of forced to traverse the array backwards. Let's investigate even further. So now we stopped using arrays as the output. What happens if we actually stop using arrays as input, right? So instead of using input as array, what if we use this string directly? Now I have shown you already that we can use strings basically as arrays, but we're going to pretend like this is not possible. So instead of this, we're going to go and we're going to say that we're going to go straight to output, right? So we're going to have an output over here. It's going to be var output, which is going to be a string. Okay, like this. So I'm going to comment this one out for a bit. Okay, so now I want to say just for the character inside of the input, I'm going to say, whoops, I'm going to say that the output is going to be output plus character. Now this is essentially what we had in the beginning, but as you can already notice that nothing is going to be reversed. Let's see if I've forgotten something. No, it seems fine. Okay, so we have hello world instead of the reverse one, right? So now we're going to try to investigate why this is actually happening, because now we're pretending like we have no way to access the characters by the index. So there has to be some functional solution to this, and I'm leading you towards it. Now, somewhere in predev, there is an implicit conversion from string to string ops, which adds extension methods to strings like for each and map. And this is also why we can use for comprehensions. And I already have a video about for comprehensions. So first, let me rewrite what we have here with a for comprehension, without the for comprehension. So we're just going to say input dot for each. And we're going to have the character arrow to the right, and now we can just move this down like this. Okay, so this should be exactly the same code. Let me comment this out. Let's see. Yes, this is exactly the same code. And since this is not our first rodeo, we have seen already how map works. So we can also switch to using map. So we can go over here and we can say input dot map. And now over here, we know that map will actually produce our output, right? So it's going to be output string, right? String. In fact, why am I calling output string? It just should be just output, right? So now we can use a val because we're using a functional construct like map, okay? But what are we going to do here? Well, we don't need that anymore, so we have just that. So it looks like we're not doing actually anything inside of map. Right, so this is just the identity function, and we have already seen the monad series. We have seen the functor laws. They basically tell us that calling map was identity is basically just making the CPU warm, so we actually don't need anything. And this is why, by following the simple function reasoning, we're actually seeing that we're actually not doing anything over here, right? This entire code it can be reduced to this, and this is why we're actually not reversing absolutely anything. So essentially what we're seeing here is that map and for each, there's simply wrong operations for the task at hand, because both of them, they traverse the array from left to right, and we need to be able to traverse it from right to left. And we have already seen how map and for each are implemented. They implemented was fold, and today we're going to learn about the fact that our fold that we had so far is actually called fold left. But so far we had only unordered collections, so we didn't really care about the direction, but now we do care. So fold, or to be more specific, fold left, is actually the wrong operation for the task at hand. Let me actually type it out so that you see that fold left actually also doesn't solve the issue. So we're going to have fold left, and we're going to start with an empty string, which is basically just this code. So it's going to be very, very similar to this code over here, right? So we're going to have the accumulation, and we have the current character. I'm just going to call it char so that it's close to what we have at the top, right? Like this. And over here is happening the same thing as happening over here. It's just that it's called ACC, right? ACC. And this is a functional construct, so we don't need this. We're just going to have ACC plus character, right? So this is exactly the same code essentially as this one over here. And obviously it doesn't reverse anything because we're using fold left. And what I'm leading you towards obviously is that there is also an operation called foldRight. And it's a convention for foldRight to swap these. So the current element is going to be here, and the ACC is going to be over here. So foldRight works essentially exactly the same way, but in the other direction. And by the way, since we're not using imperative programming anymore, we can actually remove all of that stuff because our functional solution is now super, super tiny, right? So we just have input and we have output, and we don't have anything else. Whoops. Oh my God, what am I doing? There we go, like that. Okay, let's also have an empty line over here. Okay, cool. Now everything fits into one screen. Usually in my other videos, we implement functions first and then we use them. But in this case, I showed you it before we're actually going to implement it. And I did this to make you wonder how foldRight is actually implemented, because it looks like it traverses the collections from right to left, which is fine for the strings because they're backed by arrays. And the access to the elements of the array is in constant time. So you can walk them from left to right and from right to left. But in the next video, we're actually going to implement lists, and we're going to implement foldRight for lists. And we're going to see that traversing a list from right to left is virtually impossible, or not even impractical. It's actually impossible. But we actually don't need to. We can make it look like we're traversing the list from right to left, and it's going to be very, very exciting. What we will also see in the next video is that even though sats are unordered collections, they actually can benefit from both fold left and foldRight. But I didn't want to introduce you to fold left and foldRight at the same time for many, many reasons. One of the reasons is that even though you don't see it now, the difference between fold left and foldRight is actually night and day. And another reason is that I really didn't want you to confuse them, and therefore I didn't introduce them at the same time. By the way, a quick tip about learning new things, especially in new languages. And when I say learning, I mean remembering. And when I say new languages, I mean actually normal languages, right? So not like JavaScript and C#. I mean like English, Italian, French, and so on. Studies have shown that our brains can remember different things much better than similar things. And think back to your, I don't know, Italian language at school, or whatever language you learned there, right? On one day you would learn the colors, and on the next day you would learn the family members. And to this day, you cannot distinguish green from yellow and your aunt from your uncle. So it's better to learn unrelated things at the same day. So for example, learn green, to walk, table on one day, and yellow, star, jumping on another day. Learn fold left on one day, fold right on another. All right, enough talking. Let me summarize a few things. Number one, arrays are immutable by design, ordered collections, and if they didn't have constant access time to its elements, they would be pretty much useless in higher programming languages. We would just use maps instead. Notice that arrays are the first collection that we have in more than 30 videos that required low-level knowledge of memory, and yet arrays of strings are what is accepted by most main methods in most programming languages. Have fun explaining that to beginners. Number two, strings are just immutable wrappers around arrays, and that's pretty much all I have to say about them. Number three, lists are immutable by design, ordered collections, but they are unidirectional. Every time you walk from left to right, there are no issues, but every time you want to pretend as if you're walking from right to left, they require some very delicate treatment, as we will see in the next video. However, lists are usually the first ones introduced to functional programmers because they're essentially the canonical representation of a recursive data structure. And also, the basic implementation of lists are very, very trivial to implement, and therefore they're very well suited for junior developers. And also for the same reasons, they are the default collection in the Scala standard library. So if I just open the console, I just go to Scala and I just say sequence of 1, 2, 3, what you'll see is that the type is actually going to be sequence, but the implementation is going to be a list. Okay, let me close that again. Number 4, linear recursion is required to implement lists. However, lists are a degenerate version of trees for which you would need, well, tree recursion. And so vectors, the ones that we pretty much haven't talked at all about them today, they are, at least in Scala, implemented as a mixture of trees and arrays. In Scala, a vector is a tree in which every element is an array, and the size of the array is chosen based on your JVM version to make sure that these arrays are cached as much as possible. And so you can fastly insert and retrieve elements on any side of the vector, and behind the scenes, sometimes additional memory will be allocated for the arrays and sometimes not. One of the most important facts about vectors is to know that they're immutable. So you get all the benefits from the functional work, right, from the immutability, and you get all the benefits from the imperative world of the arrays because, as I just said, vectors are backed by trees in which every element is an array. So you get, so the algorithmic complexity of the access to the elements is effectively in constant time. Now, there have been issues in the implementation of vectors prior to the version 2.13, which is going to come out very soon, and it's going to come out with an entirely new implementation of the collections library, and I'm sure that the issues with the vectors are solved, and the issues were related to concurrency, by the way. All right, so that's pretty much all I have for you today. I just wanted to introduce you to arrays and also start the conversation about the ordered collections and especially about foldRight. We're going to have dedicated videos for foldRight. In fact, I believe in the next video we're going to implement lists, and we're also going to start implementing foldRight in there. And that's pretty much it. It's been Vlad, devinside.com. Like this video if you did, subscribe if you want to improve the developer inside you, and if you find my videos valuable, consider supporting me on Patreon, and most importantly, take care.